Alright, so I'm going to be going over a type of buffer overflow attack. It's called the return to libc attack. Now, this type of attack is used as a way around the non-executable stack prevention technique that works against the traditional no-ops-led buffer overflow attack. So what this means is that even if you were successful in finding a buffer overflow vulnerability, which means that you can write past your buffer, write past your EBP and your EIP registers, you still will not be able to execute your malicious code that you've injected into the stack. So a way around this is to use a common function in C programs, which is a libc function specifically called system. So system takes in a command and it executes it as a system call. What we want to execute is a shell. So let's go ahead and get started here. The first thing that we have to do is set up our environment. So we have to turn off address space randomization so that we don't have to guess the exact address of the stack. Alright, so that's been turned off. The next thing that we have to do is find a vulnerable program. So I've already written a program and I've compiled it, but I can go ahead and show you the contents of the program. So it's super simple. It has a buffer of size 5, and clearly I don't check the size of the argument that's passed in before I do the string copy. I'm gonna go ahead and recompile this just so that you can see the flags that I use. Okay, and I'm also going to be changing the permissions on this file. Okay, so let's go ahead and run this binary in GDB. Alright, so it exits normally. So what if I were to give it an input that is much larger than its buffer? So it would overwrite past the EBP pointer and onto the return address. So let's go ahead and do this. And I'm just going to try 20 for now. Alright, so with an input of 20, we can see here that we overwrite past the EBP register and we write into the return address, or the EIP register, only 3 bytes. So we want to see how much it takes to completely overwrite this EIP register. It looks like it'll just be 21. Let's go ahead and just check it. Alright, so it looks like our return address has been completely overwritten with 21 bytes. Alright, so what we need to find now is the address of system, exit, and bin bash. So let's go ahead and find those. And we can do this all in GDB, so I'm not going to close out of this. Whoops, meant to write system. Alright, so these are the 2 libc functions that we're going to be using. So I'm just going to label these. Alright, and the last one that we need is bin bash. So we can also find this one in GDB, and you can actually find this several different ways. You can go ahead and create an environment variable that points to binsh, which is just a symlink to the currently configured system shell, which happens to be bin bash. The other way is to just do this through GDB, which is what I'm going to do since I already know the command. Alright, and I'm just going to be pressing enter. All this just is passes through, goes through the next environment variable. Okay, so we found bin bash. So we found shell bin bash. What we want is only this part of it. So we're just going to keep trying addresses until we get to the one that we want. Let's try A. So that's LL. Let's try C. Okay, so it's D. Alright, so now that we know this, now we can go ahead and craft our payload. So again, I'm not even going to close out of GDB. I am going to, however, clear the breaks. So we are going to write 17 A's. So why 17 A's? This is because we know that we completely overwrite the return address with 21 A's, or with the size of 21 characters. So we want to overwrite that address space with the address of system. So we have to go back 4. The the address that goes in the next 4 bytes is going to be the address of exit, so that we can close this program properly instead of crashing when we're done. And finally, the next 4 bytes, it's going to be the actual argument that's going to be passed into the system call, the system function, um, which is going to be bin bash, so we can open a shell for us. Alright, so this should work unless I made any typos. Alright, so it looks like we have a shell. Looks like we're seed. Yep. Oops. Okay, there we go. Now we're back in GDB. So that's it for this attack. If you noticed, I did this chmod here for this program to see if I could get root access. When we do this system function, when we call the system libc function, what happens, it's actually a protection mechanism in Ubuntu. It just drops all the privileges. So that didn't work for us in this case. What we would have to do is try a different function that actually doesn't drop these privileges for us, or we can ensure that we have um, uh, a different shell. We can use a vulnerable shell instead of this one, which drops the privileges. All right.